Good afternoon, friends. Today we are going to start a new topic in the series of differential equation, higher order linear differential equation with variable coefficient. Higher order differential equation with variable coefficient is the similar to constant coefficient, but here some minor changes. Their method are we change in variable coefficient in the form of constant coefficient. So there are some methods to solve the equations. To know about the differential equation with the variable, the objective is the student know about the differential equation. What is the differential equation with variable coefficient? How to be solved and how to find out its CF and PA. Same procedure will be we adopt to find out the CF and PI. But first we have to change. First, we have to change a variable coefficient differential equation in the form of constant coefficient form. And same method we apply for find the CF and PA. So after find CF and PA, we write the complete solution of a differential equation. So after this lecture, student will find the one or two methods to solve the differential equation of with variable coefficient. So student, all the best. This is a new concept for you. So please take care and keep focusing on that method. Let's start. Dear students, first I want to tell you about what is the variable coefficient. See, I'm writing a differential equation like this. F now we see this equation. R term which one in this term we see in this term d2y dx. So the order is equal to okay. Now the coefficient of this coefficient here dy upon dx coefficient is x plus 1. Here y coefficient is so there all coefficient with derivative all coefficient of derivative are variable. Okay, in the form of f. So a differential equation is called variable coefficient differential equation. If if this can be written as written or all coefficients are in the form of function or each coefficient, this coefficient are the form of fx. So I am writing a differential equation. I am writing differential equation like this: x square d2y dx. Here the coefficient is variable x dy upon dx plus y equal to 0. This equation is called this type of differential equation is called variable coefficient differential equation with variable coefficient. Okay, this type of equation is called variable coefficient equation. And now there are some methods to solve this type of equation. Now, the step one, first we change the equation in constant. There are some methods to solve the differential. Okay, so देखो, first one is homogeneous differential. If a differential equation is homogeneous form, then we use a other method. This equation is called Cauchy Euler. Second, exact form of differential. Exact form of differential equation is the another form of differential equation where we check the equation is exact or not. So in first order, mdx plus ndy form is called the exact form. But here we have the another method to check the exactness of the equation. Third one is third one is complete when one CF solution is known. Here one CF solution is given like y बराबर e की power x. That in the exam we write a differential in the exam we find a differential equation and they write the y power e की power x, y power x square, y की power e की power 2x is the one solution of differential equation. Then we have to find the another solution of differential equation. Now for change in independent means we change the independent variable. Why the replacing something like dy upon dx, we change in x as z and fix normal form of differential and fix a method of variation. The sixth method we will use to find the solution of a differential equation with variable coefficient. So we discuss one by one in the lecture and take the example of one by one. So first, today we are going to start the Kochi Island form. Now, Kochi Island form. Kochi Island form means is also called homogeneous differential. Here in this differential equation, the degree of variable is equal to the order of derivative. In the differential equation, the degree of variable means the variable की जो degree होगी it equal to the order of derivative. वो order of derivative के equal होगी. Means if हर term in each इस टर्म में जो वेरिएबल के ऊपर पावर होगी उतनी ही ऑर्डर की डेरिवेटिव होगी. फॉर एग्जांपल एक्स स्क्वायर डी टू वाई डी प्लस एक्स डी वाई अपॉन डी प्लस वाई डी. अब here you see you see that the power here variable power 2. So and here the order of derivative is here derivative power is 1, order of derivative is so in this term order of derivative is equal to 2, degree of x is equal to in its term order of derivative is 1, degree of x. So this is called So this is called homogeneous differential equation with value. With variable. Now, how can we solve this? We take an example of this. Let a differential equation. Let a differential equation with variable coefficient. A0 x square A2y. So let we take x is equal to a की power 100. Okay. So z become log v. Now dz upon dx is equal to 1 upon. Here we replace dy upon dx. We can write dy dz dz. No. So dy dx we can write dy dz upon dx equal to 1 upon. So x dy dx is equal to dy upon dx. And we take d upon dz here. Okay. Let's see again. In this type of differential equation, we replace x is equal to e की power z. X बराबर e की power z. So log x becomes z is equal to become log x and dz upon dx becomes 1 upon x. 1 upon x. Now dy upon dx we can write dy upon dz and dz upon dx. So dy upon dx is equal to dy upon dz 1 upon x will multiply here. So become x dy dx upon dy upon dz. Okay, and d upon dz proportional to we take d. Similarly, d square x square d2 or dx2. Here this can be written as dy and this is d minus. Similarly, x cube d2 y upon dx cube becomes d minus 1 d minus 2. This time we will follow to solve the equation. Now I take the example. So example first. X square d2y dx2 plus 3 minus 3x dy upon dx plus y log x sin log x plus 1 upon okay. So here this is homogeneous form of differential equation. So we replace x is equal to that means log x becomes and dz upon dx. Now dy upon dz now we replace and one so this becomes d minus 1 y plus y is equal to log x can be written as z sin z plus 1 e to power. Simply we replace x by e to power z and log x is equal to z. Now we can write like that t square minus d minus 3 d d plus 1 is equal to z sin z d this becomes d square minus 4d plus 1 y is equal to z sin z is equal minus z plus is equal. This is becoming our equation. Now we see very clearly that all the function, all the variable become the constant coefficient. So it can be easily show. It can easily solve. Now we now auxiliary auxiliary equation m square minus 4m plus 1 is equal to 0. M we get m m is equal to minus b4 plus minus b square 16 minus 4 upon 2. Here we get 1 plus minus 3 is 4. Okay. Now the CF we can write like that. C1 e to the power 2 plus z plus C2 e to the power 2 minus 102. You can write the shape in the form. You can write the shape in the form of hyperbola also. Okay. So C1 e का power 2 plus 103 plus C2 e to the power minus e to the power 2 minus 103. Now for Pi. Now for Pi. Pi is equal to we get Pi is 1 upon 2 square minus 4d plus 1 z sin z e to the power minus z plus e to the power minus. This is the form of Pi. Now now you solve this by separate the 1 d square minus 4d plus 1 z e to the power minus z sin z plus e to the power minus z d square minus 4d plus. Now first we solve for e to the power minus z to e to the power minus z is here z sin z and fourth d plus 1 d plus alpha, so d plus 1, d minus alpha, so d plus 1. So d plus alpha, d minus 1, minus 4, d minus 1, plus e to power minus z. Again here we put d minus 1 plus square minus 4, d minus 1 plus. Okay. Now, z sin z is equal to open this d square plus 1 minus 2d minus 4d plus 4 plus plus e to power minus z d square plus 1 minus 2d minus 4d plus 4 e to power minus z z sin z d square minus 16 plus 1 plus 2 plus 6 plus e to power minus z d square minus 60. Sorry, only e to power minus z. So we can already we can put d. No, sorry, minus alpha here. So we get here we can write d square minus 2d as it is. No change. D square minus 2d because this is the case of e to power alpha z. Now e to power minus z dz we can write e to power z z imaginary part upon e to power minus z z e to power z. This can be written as okay we know from here and as it is imaginary part as it is and this will become e to power minus z upon 1, 1, 2 and 6. It becomes now now e to power minus z we can put here d plus iota. So this becomes e power iota z z d plus iota whole square minus 6d plus iota plus 6 plus e to power minus 0. This type of question, this type of PI part, we already solved in previous question when we had taken x sin x. Okay. Similar this is become z sin z. and we can write sin z as a imaginary part of e to power z. So this is become z item minus 1. Now z upon d plus item whole square. We open that d square minus 1 plus 2d item minus 6d minus 6 item plus e to power minus z. So e to power z item minus 1 z d square plus 2d item minus 60 minus 6 item plus 1 plus e to power minus z. So we take out 5 minus 6 item. Very lengthy question and very carefully attempt to it. 5 minus 6 item. So it will become 1 plus d square plus 2d item minus 50 upon 5 minus 6 plus e to power minus 0. So this is become that now e to power z item minus 1 1 upon 5 minus 6 item plus d square plus 2d item minus 6d upon 5 minus 6 item. We take expand this. Now we expand d square plus 2d item minus 60 upon 5 minus 6. Okay. Now we multiply. We take z inside this item minus 1 5 minus 6 item. This becomes z. Z d square z is equal to 0. 2d is equal to 1 to 2 iota minus 6 upon 5 minus 6 iota. This is we get by inside multiply z. Here z multiply with 1. So it becomes z. Then z d square z is 0. 2dz is equal to dz is equal to 1. Dz is equal to 1. So this becomes 2 iota minus 6 plus e to power minus z1. By by solve that we get iota minus 1 5 minus 6 iota 5z minus 6 iota z minus 2 iota plus 6 5 minus 6 plus e to power minus z upon. Now just simplify for iota. Just simplify the question for iota and we get the imaginary part is the solution of this equation, this differential equation. So we write e to z iota minus 1 as it is 5 minus 6 iota is the whole square. Here 5z plus 6 is side and iota 6z plus e की power this. Now we can solve by we can open this or can be right in the cos theta and cos x and tan x. After solve it, we find the imaginary part e की power minus z where the length is 6 by 61 z cos z plus 5 by 61 z sin z minus 156 61 square sin z plus 252 61 square cos z plus 210 61 whole square. So this will be become we can put by solving that d as 3z upon 61 6 cos z plus 5 sin z. Student, this is very important question in Euler Cauchy equation 191 cos z plus 27. Now we put z is equal to log and get the okay. So this is the 2 we had complete solution is equal to Cf plus. I hope you understand the method. The method is the important part of this question because we have to show we have put x is equal to e to the power z and then dy upon dx x square d to y dx to add dt minus 1 and then solve it and same the equation change in the constant coefficient differential equation and we solve by pi with order method, iteration method. Now we come to the quiz on the basis of Cauchy-Euler equation or homogeneous equation. Euler-Cauchy differential equation is also known as Euler-Cauchy equation is also known as homogeneous equation. P0 is the coefficient of a differential equation is written as the form of P0 d2y dx2 plus P1 d2y and dy upon dx plus Qy is equal to R form. So P0 is the coefficient of d2y dx2. In homogeneous equation, we take x is equal to what we assume. In homogeneous equation, if you see that the first step we put x is equal to e to the power z. Okay, so here x is equal to e to the power z. Now, if we replace x in z variable, then z, what is the value of z? He asking about what we replacement done for change x in z. So we put z is equal to log x. Okay, we put log x. D minus 1 term means each. D minus 1 term show that x square d to y dx2 because when we change the d to y x square d to y dx2 we take dy upon dx is equal to dy dj upon dz dz upon d. The pi of e to power z. This is the remaining part. Pi uh, we will show in the next lecture because this is used in general method. General method to solve this type of integration for find the pi. Here e the qx or make we can say r is e to power z. So how we find out the solution? We find out the full solution by or pi by general method. Okay, students. So thank you very much to concentrate on this topic, and this is very important part of the differential equation, and each method have its self significance. So very carefully, very concentrating way you have to attempt this question because you see in lecture we take an example of differential equation or this is so lengthy to solve it. So this type of question in exam you have to attempt on the time period. So keep practicing, and any doubt you can contact with me. Thank you very much, friends. Thank you.